Okay. Introduction to machine learning. What exactly is it, and what can this do for us? Why should we care? Why do we even want to learn about machine learning? A definition, which there's probably a million if you go out there and look, there's many different ones. One way of thinking about it might be that it's a field of study that gives computers the ability to learn from data without explicitly being programmed. So you're not necessarily telling the computer, take the column X1 and multiply it by 10, and then take column X2 and then multiply it by 3. It is learning those weights and those parameters by looking at the past historical data. So if you give it prices of a house, like historical sales of a house, what have houses with 3 bedrooms and 2 bathrooms sold for in the past versus what have houses with a lot size of 5,000 square feet sold for in the past? And looking at that large set of data, we have algorithms that have approaches for learning weights and for learning how to apply that math, optimizing those mathematical functions, so that you don't have to explicitly tell it that. And we're going to learn those algorithms in this course. One question that emerges a lot is, well, what is the difference between artificial intelligence and machine learning? Are they different things? Are they the same thing? If so, how are they different? And there have been a lot of different pictorial representations and ideas and concepts around this. This one is the one that is starting to emerge, and this can change. But this is what I've seen become a common way of describing it so far. And that is that artificial intelligence is like this larger domain. It's an umbrella, really, that encapsulates a lot of things. And it's a program that can sense, that can reason, that can adapt, that can take action, that has, and that can include a large set of machine learning approaches. So it's not necessarily one algorithm or one approach. That can include a large swath of different technologies and approaches to create the artificial intelligence. Machine learning is typically referred to as the domain of algorithms that have really strong mathematical underpinnings or mathematical formulas or optimizations. Again, it's not a super strong barrier, but artificial intelligence tends to lean a little heavier on the deep learning side. So you think of neural networks and what led to transformer architectures over time. That's where you start getting into deep learning and artificial intelligence. And deep learning can be a subset of machine learning as well, though it's usually hyper-focused on neural networks specifically. So ML, I realized I put ML domains there. I was actually thinking of a few slides from now. But the important thing to think about and consider from an ML perspective is that we're enabling algorithms to learn from data. We're giving it a lot of data and asking them to learn. This isn't really magic that happens. In the absence of data, you'll have bad models. And in the absence of quality data, you'll get bad results. So data is a really strong underpinning for machine learning, and it's critical and it's very, very important. And what these algorithms are doing is they're truly detecting patterns in the data. And the effects of that is that if our data is biased, if our data has bad patterns in it, our results will have those patterns as well. So if we give a machine a bunch of resumes and we tell it, select the resumes for me to interview, and historically, we have had a preference to male resumes over female resumes, that preference will be perpetuated in your machine as well, because it's all just based on data. So it's pattern recognition. So this is some of the things that we have to be aware of. These approaches aren't really self-aware at this point, though there are frameworks to help with that. But it's really just, it's not magic. It's just learning from the data. It's detecting patterns, and sometimes for better or for worse. And sometimes we have to put up guardrails because of that. So one way that I found helpful in differentiating between, well, is this data analysis, is this reporting, or is this machine learning? I found that sometimes those concepts get confused by people who maybe like business areas or people who aren't necessarily familiar or doing that type of work every day. I found the descriptive, predictive, prescriptive paradigm to be very helpful. So if we're thinking about something that is descriptive, something that happened in your business, tell me about the claims volume experience over the last year. Tell me which claims have had, are higher risk, or which claims are costing us the most money, which customers have had the worst experience, or where are the worst reviews coming from. That's all descriptive. We're looking at what happened in the past. We're drawing conclusions from that. That's data analysis, that's reporting. Predictive is, I don't know what's going to happen in the future, but I want you to look at the history of what's happened in the past and give me a confidence, a probability on how likely you think that's going to happen. What's the likelihood that that's going to happen? What is the likelihood that a customer is going to leave in the next month? They haven't left yet. It's not historical. It's trained on historical data, but it's predictive. Can you predict to me what tomorrow is going to, what's the weather going to be tomorrow, even though it hasn't happened yet? So that's the predictive domain. That's really our sweet spot for machine learning. And that's a lot of things that we're going to talk about in this class, is that predictive domain. When we think about prescriptive, that's recommending an action to take, which is also a domain of machine learning, typically referred to as recommendation engines. We will not be covering that in this course. It's a whole nother world and terminology, and I love it. And if you guys are interested, I'd love to chat more about it. But recommendation engines are like Netflix. You get onto Netflix and it says, hey, here's some new movies for you to watch. But your profile looks different from your parents' profile, which looks different from my profile, which looks different from my kid's profile. So they have recommendation engines that's not just based on historical data, but to you specifically from a personal perspective. What have you watched, and what have other people like you watched, and what have other people like you liked? That's prescriptive. We're suggesting an action for you to take. So you'll see that a lot. Amazon content recommendation engines are prescriptive. Assistants, you ever have your Alexa pop up and tell you, hey, I have this new feature. Like, would you like to use it? And you say, no, that sounds terrible. Or you say, yes, that would be actually really, really great. That's a prescriptive thing. It's suggesting that you take an action. So, and these things can all come together, right? We're going to try to isolate them so that we understand them as individual units, just because it's easy to do that, to break down concepts. But in the real world, when you implement something, it can be a combination of these things. All right, I already started talking about some examples, but I'll just talk about other ones at a very high level. Everybody knows that self-driving cars use AI. What they use specifically is something called vision, or a vision system. So they take cameras, and they have tons and tons of cameras all over the car, and they take a lot of videos, and then they do what with it? Well, it's kind of complicated, actually. And that's why I was saying some of these things get complicated. It doesn't do necessarily one thing. It's going to have a lot of things that it does. It's going to have object detection, where it detects object. It's going to be able to sense your speed, sense how far away something is. Not just is there an object, but how far away is it? How quickly are you approaching it? What are the rules of the road? How do these things play into that? So there are a lot of they become whole systems, really. So that's kind of the most complicated end, is the self-driving car. But if we think, at a really basic level, predicting illnesses is one that is very common. You can use machine learning for. So you can pass images of brain scans to machine learning algorithms, and they can try to detect if there are certain anomalous things in them that you're particularly looking for. Maybe you're looking for tumors. So you can do like tumor detection with brain scan images. Credit worthiness, should I approve you or not approve you for a credit score? You can do the same in claims. Should I approve this claim or deny this claim? Somebody has a simple pregnancy claim and it's kind of straight into the line. You might say, well, why don't you just have rules for all of that? Why don't you just say if they make this much money, or if they have this, do this, and if they have this and do this? What we found is that sometimes when you get into large sets of data in large situations, you end up having these like decision trees that could be thousands of things long, and it really becomes intractable. It's unfeasible for us to do automatic claim approval given all the rules and all the possible policies and all the possible people that could occur. So instead, we can lean on our historical data and patterns to approve an individual. I might never recommend that you decline an individual, but that's another story. A lot of people get in trouble for that. So that's some of the benefit of machine learning, is even in situations where we could make a rules-based system, it just may not be practical or feasible, and machine learning can accomplish it just as well, or close to 80-90% as well, with a tenth of the effort of that. Ranking on social media, CV in agriculture. Oh, I had a fun story about the agriculture one. So a relative of mine builds an AI system for a company that flies drones over farms, and they count their head count of their cattle. Because apparently some of these places have thousands and thousands of head count, and it's really infeasible for a human to go out there and try to count them, because the cows are moving around. And by the time you like get this section done, and then you move over here, and then that cow moves over there, and you're like, did I get that guy or not? I think I got 79. I don't know. They use drones now to help them do their head counts, and this affects their insurance policies. This affects how much food they need to order. You can think of like all the things that it might be useful to know how many cows you actually have. So there are real applications where people are using these targeted emails. So I actually built my former company, an email recommendation engine that says, given this information about you, and given this this type of email that we want to send, when is the best time to send it? Are you the type of person that's like, send me all 10 emails on day one, I want to read them all and I want to be done with them, I never want to hear from you again? Or are you the type of person that's like, hey, one email a week, every week for the first 6 weeks, I want a very consistent email? So there's different types of people in the world, and there are different ways in which they respond to things. So Amazon and Netflix and such have this really down, but your own companies, I guarantee you they have marketing companies as well. And I guarantee you there are machine learning use cases in marketing for that. Q&A based platforms, fashion industry is a really, really fun one. One of the most well-known, well-renowned neural network data sets is actually a fashion data set. It's called I almost said MNIST. That's the number one. I'll look it up for you guys, but it's the fashion data set, and it's all these pictures of these clothes, and you have to try to decide, is that a dress? Is it a shirt? Is it a pair of pants? Because people are going to want to filter these things online, and you could go in and metadata tag each and every image, or you could use AI to tell you, or machine learning here. I may use that word interchangeably, by the way, but machine learning to tell you this is a pair of pants or this is a pair of shirt. So that is a real application. Do you guys have any applications that you know of or can think of?
No.
That's okay. No? Maybe?
Well, at Race for QP, we did machine learning. Machine learning was part of it that predicted where rail is most likely to break.
Cool.
The coming year.
That's pretty cool. So you're doing preventative maintenance based on that probability prediction. Yeah, that's a huge one, by the way, because it is substantially, you save a lot of money by fixing something before it breaks, as opposed to after it breaks, it causing additional damage, and then maybe you're like halfway between stations, and then that's more money. And I don't know anything about trains, but maybe you got to haul them or something. So there's a lot of, we had in this class one of the years somebody who worked for a power company, and similar thing. A lot of preemptive predicting when something's going to go wrong so that you can address that before it happens.
Yeah, and I'd love to see I work in health insurance, I can't really speak to what my company's doing or not doing, but I would love to see insurers doing more with the data that they have in that predictive preventive space.
Yes,
You have all this data about people, help them with their data.
help them.
Because they don't,
Yeah,
they're not able to.
I love that. We have a model that predicts when we should follow up with someone in order to give them the optimal care. So we have nurse case managers on staff, which we actually pay for, and then can consult these patients and help them get better care. And what turns out is we ran that as a 2-year pilot, and we found out we were able to prove that the ROI on that was so high that we funded an entire team, and that's all they do. So everybody says AI takes away your jobs. This is a story that AI actually created jobs that didn't exist there before. And it's because we were able to leverage this model to predict when should we follow up with people, when should these nurse case managers interact with them to provide them better support. And it had so many great outcomes. Customers were happier because nurse case managers were telling them, hey, did you know at work you can request a stool for your torn ACL? You should request a stool, and helping them have a better recovery experience.
Yeah.
And then because of that, they recovered sooner. And then we benefited as an organization because we had a shorter duration of claim. They got back to work sooner. They got their full paycheck sooner. It was a really great thing. So that's the sweet spot right there. If you can help people and make money at the same time.
Yeah.
So let's talk about your first exam concept. I probably will ask a question or two around this. And that is that there are 3 different types. Well, there's actually a lot of different types of machine learning. There's 3 in this picture that we're going to talk about. And like I said, this course will not cover reinforcement learning. I'm going to mention it here so you're aware of it as you're exploring the internet, but I will not ask you any questions on reinforcement learning, and it won't be part of this course. So let's talk about unsupervised and supervised learning. I'm going to jump back and forth between these two, and I do need to get some water here too. What are we at? 57. We're going to go 3 more minutes, and then we're going to take a break, and I'm going to get some water because my mouth is dry. So supervised and unsupervised and reinforcement learning. So I said I was going to jump back and forth. So supervised learning, the simplest way I can put it is you're learning from labeled data. So something has happened, and I have labeled data that historically tells me that has happened. So house prices. A house has sold, and I know what price it sold for because I have the sale price online. Or somebody has a disease in the healthcare industry, and they either recovered from the disease or they did not recover from the disease. Or somebody filed a claim and it was either closed in 30 days or it wasn't closed in 30 days. So you have something in, a key term here might be the word ground truth. So you have something in data science called a ground truth that tells you what reality really is and how that has happened historically. So when we look at supervised learning, we have 2 classes here. This is an XY plane, and let's assume that we have 2 different flowers. We have 2 different types of flowers. We have flowers that are a little blue circle, and we have flowers that are a green X. And we can say that we can decide the difference between a green X flower and a blue circle flower based on this decision boundary here. So I can say that if the values of X1, X and Y, X and Y fall on this coordinate above these values, so this, let's say this is 1, 1. So if it's 1, 1, or if it's 2, 1, or if it's 1, 2, for example, then it's a green X. And if it's below that, if it is 0, 1, or if it's 0, 0, or if it is 1, 0, then it is a blue circle. So we can create a very clear decision boundary, and this is maybe a graphical representation of something that we will learn, which is linear regression. That's going to find the best fit line. That's at y equals mx plus b. You guys might be familiar with. So that's supervised learning. The main thing I want you to take away here is labels. There's labels. There's ground truth data. We know what happened. We know what we're looking to answer. Maybe you don't know what it's going to look like in the future. Like, I don't know if this claim is going to close in 30 days. That's good. That's a question we're trying to answer. That's what we're trying to predict. But you have labeled data. Netflix, they know you watched that movie or not. They know you watched all of it or not. They know you watched half of it or not. Unsupervised learning is clustering data, unlabeled data. So in this situation, we've got a bunch of dots here. We've got I shouldn't say 3 classes. We've got a bunch of dots that have no colors. Imagine there's no colors. So this is a situation where I'm going to whiteboard. Okay, there's no colors. There's just a bunch of dots. And your stakeholder tells you, hey, I've got all this information about customers. I know all their demographics, and I know all this stuff about them. I want you to put them into 3 groups for me so that I can market to them differently. And you're like what kind of groups? And I don't know, 3 groups that are similar to each other. Okay, I guess I'll do unsupervised learning. So that's where you create an algorithm, you implement an algorithm that groups data together similarly. So maybe, even though this looks like a big mass, what ends up being the result is our algorithm that we implement, which we'll talk about later in this class, says, hey, here are the 3 groups that I've defined for you. Now, there are some complexities with unsupervised learning. You have to know how many groups you want in advance and how can you possibly, so there's some approaches we'll talk about to navigate that, but in unsupervised learning, what I want you to take away, that's why I said it wasn't colored, and then when we do unsupervised, then it becomes colored, is that there are no labels. So there is no ground truth that's saying this person belongs to class 1 or this person. You are literally making up groupings, not making up, but you are using an algorithm that creates groupings and classifications based on metrics. Now, if you do it on an XY plane like that, it may not necessarily make a lot of sense, and you may think, why would we ever do that? This is kind of assuming there's only 2 features. This is kind of assuming maybe we have age and we have height. I don't know. That makes no sense. But let's say you've got 1, 2, 3 demonstrating purposes here. I guess they're toddlers. So we've got age and height here. They're all kids and they're very short. And so this is assuming you have 2 features, but you can see how once we get into what if you have 3 features? What if you have 4 features? How do you represent 4 features? It's hard as a human. Maybe I can look at two dimensions. Maybe I can look at 2 dimensions and visually say this. Once you get to 4, I have no way of doing that unless I'm going to represent one of the dimensions as sound or color. And then what about 5 dimensions? Now what about 700 dimensions? So that's the power of unsupervised learning, is I can create clusters for you, group peoples together with a large number of features. By the way, I'm probably just going to start using terminology and you guys are going to catch up. But this is what a feature is. It's just a variable, just so you guys know. So we have ID, maybe we have age, maybe we have salary, maybe we have salary, maybe we have zip code. This is a feature. We'll talk more about this when we talk about linear regression. But just so you guys know, if I say feature, I mean variable. It's just a variable in the data. And I might call it X1.
Oh, Emily?
Yeah.
Carmen asked, and I just noticed this from like a half hour ago, if you were sharing your slides on the screen.
Oh, no. Is it?
I just went back to Steve, whatever it's called, I don't see it on the screen.
Carmen, can you see the slide? Oh,
I don't think she's
I think I have to add her to the stage because she was having connectivity issues.
still on
There
elevation.
we go. Carmen, can you see now? I think so. Let me ping her real quick. She might have popped off, so.
Oh, she just said reply back and then, oh, no, it's 7:44, can't see the screen.
Yeah, she may have popped off if she couldn't see it, but I assume she'll watch the recording here. Now, when we talk about, so we have unsupervised learning, no labels. We just want to group things together in ways that are similar. An example of this, by the way, is when I was graduating from college from my undergrad, I created a beer recommendation engine for my first project. It was actually an unsupervised learning implementation. So I took a bunch of beers and found beers that are similar to each other, and I recommended you beers similar to ones that you had tried in the past based on a clustering strategy like that. So that's an actual example of one that you could do for unsupervised learning. Reinforcement learning is it's like playing a game. So you guys know that game Pong, where the ball goes back and forth. In that game, you want to ask the machine to learn over time and make decisions. Oh, you guys know how, I got a better example, and I'll come back to Pong. You know how there's those chess champions that play the computers? The way those computers learn how to play chess and the way they get so good at it is reinforcement learning. That's what they do. They learn over time how to play the game. So let's go back to Pong, a more simplified version than chess. What reinforcement learning does is it has a couple different things. It has the state that you're in, the action you're going to take, and the reward you get from doing that. And so if you're playing Pong, maybe the state is the ball is attached to the other person's paddle, and the action you're going to take is maybe you're going to move up one space, so you're a little closer to that. And then your reward is nothing happened. So you didn't lose a point, you didn't win a point. Now, the next state is maybe the ball's over here. What action are you going to take? This one, then you get your reward, and then maybe the ball goes through and you lose a point. So now you have your state that you were in when that happened. What the action that you took is maybe you moved up instead of moving down, and your reward policy is that you basically lost a bunch of points. And so over time, by going through that experience, you can teach the machine based on that reward policy to make different decisions. So it learns how to make those decisions. So it'll say, once it gets to that state again, it'll say, oh, in all my experiences that I've saved in my historical data, of all the times that I went up in this situation, I lost a point. And of all the times that I went down in this situation, I didn't lose a point. So now I'm going to go down. So it's all funded on probability and the number of times and experiences that has happened to them. And it doesn't necessarily have to be the very next step. By the way, the reward policy can be long looking. So if you think about chess, it's probably not about the next piece that you're going to lose. It's probably about how to win the game. And so there's that's maybe all I'll say about reinforcement learning, except that it's a very powerful field because I'll say one more thing. It's founded on a concept called explore, exploit. So when they came and asked us to build this email recommendation engine that would send letters out to customers and then meet these, each email had an objective. So somebody was supposed to watch a video for X months or click this link. There were success criteria that we could measure with each email. But they told us these are new emails and we don't have any customers that have ever done that before. And I'm like, well, so you have a supervised learning problem, but no labels for it because you've never done this before. And so we thought, well, we could just do a traditional statistical approach. where we send X number of emails to each customer profile, and we do that for every day of the 90-day experience and see which one has the highest return rate in terms of the objectives we were trying to achieve on the email. Well, we did the math and we found that the world would explode before our sample size was high enough to do that, literally billions and billions of years. So that's why it's good to run your numbers on your experimentation and see how long it's going to take you to get that. How many people do you need and how long is it going to take you to get there to build that confidence? So we said that's not reasonable. We can't do it. And this is when we approached it with a reinforcement learning approach. We said we're going to let the machine learn over time. So basically in the beginning, it sent emails at random times to people, but then it collected that information. And then we knew over time, and we implemented an algorithm where it could search that space efficiently. So over time, it made not the best decision that could ever be made because it's based on that random start of it sending those emails. But once it found a day that worked pretty well, then it started doing that more and more often. It's something called a greedy approach. And so it was able to send those emails and learn over time. So basically what you do in those types of frameworks is you usually say, be random 100% of the time for the first X amount of time for the first week. And then for the next week, be random 90% of the time, and the other 10% of the time, send on the day that you actually found was the best day based on your historical data. Then you start to move that slider down. So then by the end of the experiment, it's only sending out random letters 10% of the time and 90% of the time. So it's only exploring 10% of the time, and 90% of the time it's exploiting what it's learned, where it's actually sending to its best, the best data send that it found was statistically probable. So reinforcement learning, cool stuff. That's all we'll say about it. These are the different types of machine learning algorithms by domain. So I'm going to stand up on here. So we have machine learning at the top. We have supervised learning, unsupervised learning, and like I said, reinforcement learning. We won't talk about Q learning, R learning, but we will talk about some of these. So under supervised learning, there's classification and regression. By the way, I found this very confusing. Like classification, regression, supervised, unsupervised, when I first started learning about this. So I think this visual is helpful to show that classification and regression are subpoints of supervised learning. They're both supervised learning approaches. So we'll talk about what those mean more as we go through the course. You can basically think of it like this. Classification is categories. Apples, bananas, pears. Binary, yes, no, 1, 2, 3. Regression is numbers. So I want to predict the price of the house, $173.52, $174.52. So this is something called a scale, where every number in between another number is valid. So it can range from 0 to whatever number. This is something called discrete categories. So they're discrete. There's n number of categories. And you can't be in between a category. It could be one category or another. That's what classification is. And then clustering, we talked about, that's what clustering is. It's unsupervised. Most of the unsupervised techniques that we'll talk about will be clustering. So the ones we'll cover in this class. In classification, we will talk about decision trees, and we will talk about random forests, and we will maybe talk about k-nearest neighbors. In regression, we will talk about linear regression, and we will talk about, we will talk about neural networks a little bit. No, linear regression is, the only one we'll talk about for regression. And then clustering, we will talk about k-means clustering. So those are the ones that we'll, just so you know, there are other algorithms, and we may touch on them. I did choose linear regression and logistic regression for very specific reasons to get to deep learning. So even though they may seem like more of the foundational models, it is important that we understand those formulas, because once we get to neural networks, there's some really cool stuff that happens that are all transformations on those formulas. Okay. This is the last thing, and I know I said we'd take a break, so I promise we will. This is the ML life cycle. Well, in this class, we're only going to talk about model training. We're just going to talk about model training. In next class, we're just going to talk about evaluation. But I want you guys to be aware that there are all these other things that go on around model development that we won't necessarily allude to or talk to, but we're not going to teach specifically. So there's a whole process for data collection. I'm probably just going to hand you data sets, and they're probably going to be fine. But when you implement this like in the real world, there's a whole thing for data collection. There's a whole process of exploratory data analysis, but you guys already took a course on that. A lot of times there's data annotation, so we would love if all of our data was labeled, but it's probably not. So we probably don't have a ground truth data set. We might have to annotate it. Then you get to the model training and evaluation. So unfortunately, when we think about like these data science roles, I would love if my data scientists could do model building 80% of the time, but in reality, you're spending a lot of time on these other things, model deployment, monitoring, and retraining as well. Just so you guys are aware, there's more things in the life cycle beyond building the models, but this is where we'll start. Okay, let's take a break. Oh. So weird. So it doesn't. Oh, I think.
So the water down the hall to the left or the right?
It is down this hall where he just walked, and then it's on the left side. I'll actually walk with you over there. Let me pause this here real quick.
I'm afraid of looking.
let's jump back into it. Thank you. Was that Carmen? Yeah, thank you, Carmen. I appreciate that. I apologize. I did not have the share screen on. Share screen is now on. That won't be in the recording, but the slides are all available. So sorry, Carmen, that was probably challenging at that moment. Thanks for letting me know. So these will now be visible on here. So if we look at, let's talk about Python basics. So we're going to spend the last 30 minutes here doing a quick review of Python basics. So I do assume that you guys know Python. You don't have to be experts. We're not looking for, on a scale of like 1 to 5, if like 5 is a expert Python developer and 1 is that they just started developing Python in Python yesterday, I would expect you guys to be like a 2.5. So on that scale, you don't necessarily have to be like the best Python. We're not going to do object-oriented programming. We're only going to do functional scripting. But all of the assignments will be in Python. And so you will be implementing code in Python. It will be very useful. So for that reason, we are going to go through some really a refresher on the Python basics. Just to reorient on this. And basically, if you guys have questions, let me know and we'll work through that. And then I'll drop some resources that other students have found useful in the past for learning Python and getting up to speed. So Python is a programming language that really rose, and I'm realizing I should probably do like an introduction to Python, which I have on another slide here. So one of the notebooks in here is Introduction to Python, and that is the one I'm going to download and walk through. I'm going to pop back and forth. I'm going to drop it in my my Colab folder here. And okay, we're going to walk through this. So Python is a really powerful language that has really risen in popularity. It is not the only language that you can program in to do data science or machine learning, by the way. Another really historically popular language, for example, is R, if you guys are familiar with R. However, that's there was kind of this battle between like R and Python. And actually, when I started on my team, I set our team out to be language agnostic because R was so common when you were going through hiring that some people knew Python, some people knew R, some people knew both. And the battle seems like it's really waned now. And now Python has come out ahead and R is really only used in an academic setting. So you might do academic research, like cancer research on mice, and building models around that is something that I've done in the past. But I've not seen R applied, with the exception of maybe one place, applied like in a professional industry. And the only reason they do use it there is because they've used it historically, and it's kind of hard to replace their infrastructure. But typically Python is really the language that won. And the reason Python won is because of it comes down to two things, in my opinion. One is the versatility of the Python language. So Python can be both an object-oriented programming language, or it can be a scripting language where you're just executing one line at a time. And it turns out that application developers who build things into actual software, like object-oriented programs, and data scientists who want to quick and dirty put something together like the scripting. And Python was a language that could enable data scientists to program something quickly, but then when it was ready to go to production, software engineers and machine learning engineers could reframe that code into an object-oriented paradigm and actually use it to build safe and secure and stable applications. R is only a scripting language, for example, and so it wasn't able to serve that software end. So Python can really serve the needs all the way from the experimentation phase all the way up to production delivery. So it's a rare niche. In addition to that, it's just a very, very friendly language to use. So when you go to create things and when you read through code at times, I don't have a good example here, but it feels like you're reading human language. It'll say for fruit in list of fruits, do something with fruit. Like as we program, I think you'll understand what I mean, but it's just very friendly. Whereas other languages like Java, for example, tend to have a lot of ceremony around them. So Java will say, to create a hello world, you have to do public, static, void, main, and like, what does all of that even mean? So it's just the way that they develop this is very friendly. It's very easy to use, object-oriented or scripting, and it has like high code readability. And some of the cons is it is a little slower than other languages. So if you are working for Amazon, you are working for Google, you probably aren't programming in Python. You probably are programming in Java, and you probably are programming in those really like detailed high-level languages, because when somebody places their order on Amazon, speed matters, and they do have to get that information out quickly. But really, you're only looking at like the Fortune 100 companies that are doing programming and serving models in different languages. At that point. And so for 90%, 99% of people and teams and applications, Python is very much the common language, even though it's slightly slower at times. So if you guys didn't know, there's like different types of programming languages. The lowest level of code is called bytecode on a computer, and they're literally all zeros and ones. And I guess technically, if you really wanted to, you could write code in bytecode. I don't know. It'd be really hard because it's hard for us as humans to read that code and know what it's doing. So as you move up this at the higher level at Python up here, it's something called an interpreted language, which means it's very easy for us to understand. But the process it has to go through in order to translate the word for into something the computer understands is actually quite a bit of time, computationally, I mean. And so because there's all these translation layers, it takes some time from a machine standpoint to get down to that binary code. That's the trade-off you have. Languages that are easier run slower, easier for humans to understand, run slower, because it takes time to translate that back down to the unintelligible binary code, bytecode. Languages that are closer to bytecode are harder for us as humans to understand and harder for us to program and more unfriendly to work with. So something like assembly language, for example, which I think is something that engineers have to learn to work with when they are in college. So if you look at C or C++, that might be like a middle level language where you actually have to decide, this is where I'm going to store the memory of this object. You have to do memory management. Python takes all that away. It's like, I'll handle all of that stuff for you because you don't really need to worry about that. The trade-off is it will run a little slower. Nothing that we as humans would really worry about or need to worry about. The only time it matters is if you're working at a huge company and they're trying to make an application that serves in 0.0001 seconds or something to that effect, then it matters. I think we'll skip through most of this. This is not important to mention probably anymore, especially since we're using Google Colab, but just as you know, as you go through your internet searches, there was a very substantial change in Python back in 2017-ish, an update from Python 2, version 2, 2.x, 2. Whatever to 3. Whatever, and it is not backwards compatible. So backwards compatible means that when they release newer versions of Python today, if it's 3.6 moving to 3.7, anytime, even if you're still working on 3.6, if you run it on 3.7, all your 3.6 code will still work on 3.7. It's backwards compatible. 2 to 3 is not backwards compatible. So if you get on like a Python Stack Overflow post and it's from 2016 or earlier, just just check and see if they're using 2 or 3. That code may not work on your machine or your implementation. 2 and 3 are not compatible. Never use anything less than 2, or nothing will work. So that's all you need to know. It's becoming less and less relevant that we need to say this now because we move farther away from that. Most of this you don't need to know. Most of this is just a refresher. Okay, so here's the picture that I had in the slides. If you want to know how to execute a Python file, here it is. But we're just going to work with notebooks, so I'm not even going to talk about that. There are different types of data types in Python. So what the heck is a data type? Well, we have information and we need to do something with it. And in order to do something with it, we have to store it somewhere so that we can use it. For example, we have the number 1 and we have the word apple. But I don't always want to say apple every time I want to use the word apple because maybe the numbers. I don't always want to say 1 every time I want to use the word 1 because sometimes I want to do things like add stuff to it. And then it becomes the number 2 if I add another 1 to it. And then how do I reference it? Well, we would reference it as something called a variable. So this is what a variable is. My number, you can call it whatever you want, is 1. And like I said, if I have to actually run that, print, and let's print my number. If I didn't run that, by the way, it wouldn't exist. I have to run this cell in order for it to actually store the value of 1 in the variable called my number. If I didn't run this cell and then I tried to use it, it would throw an error at me. It would tell me the variable didn't exist, and it didn't exist because I didn't run it into the program. I didn't save it, essentially. So let's print my number, and we have 1. Now, what if I want to add 1 to it? We could do my number plus 1. And now we have 2. So this is what a variable is. It gives us a reference. The reference is the word my_number to some type of object that we can then move around, we can manipulate it, we can do things with it. So we need to be able to store different types of things into a variable. And those types of things we can store in a variable are called data types. These are the only types of things, ****, that you can store into a variable. You either want to, yeah.
Your laptop is better than laptop.
Oh, thank you. That is very
If you
helpful.
wanted,
Yes, I took that out earlier and then never plugged
Yeah,
it in.
it almost happened to me.
I made the mistake one time of forgetting my charger, and that was an interesting experience. Okay, so we have different data types. So you can have a numeric thing, like what I just mentioned, with the number 1, but the number 1 is different. That is not the same thing as the number 1.34. So if we do, you can do something called type, if you ever want to see what type of something is. And that is something called a float, where if we do the type of 1, it's an int. Basically, a float is anything with a decimal. An integer has to be whole numbers, 1, 2, 7, 10. It's useful. You might think, why? Why couldn't they just call it a number and put it? Well, it's useful because sometimes you want to tell people you have to give me something and it has to be a whole number. And a really easy way to do that is saying it has to be an int. So those are these types. So we have integers. We'll just talk about ints and floats. So ints and floats, so that's an int, that's a float. There's another data type called a Boolean. And that's basically if you're saying something is true or false. And it's extremely useful for machine learning. This one is very, very important. So this is something called a Boolean, true or false. So Boolean, what's cool about them is you can actually cast them to integers. This is something called casting. Let me think of how, because I tried to do it, sorry. Let's do that there, and then let me do another one, int of false. And that is actually 0. And the int of true is actually 1. So you will see this a lot in machine learning. You will see that values that are true get converted to 1, and values that are false get converted to 0. The reason for that is because our machines, in reality, what we'll find through this machine learning course is that machines actually can't do anything with words. Like, they are incapable of actually understanding anything about a word. So everything actually has to be converted to numbers at the end of the day. So one way of converting, is this an apple, yes or no, is to convert it into binary, 1 or 0, where yes is 1 and no is 0. So that is always the nomenclature that you will see when you're working with binary classification or classification problems. The indicated event is always a 1 and the non-indicated event is a 0. So that is what a Boolean is. Boolean means true, false values. I will not get into any of these others because I just don't think they're important, except strings for sure. So if a string is, this is a string. Maybe I should do a different word. This is a string, there we are. And what you can call type on it. So anything between these quotation marks, you can use double quotes, you can use single quotes. They're the same thing. They are both string values. And what is interesting about these strings is you can actually slice these. Fun fact, I'll let you guys explore more around this, but this is a string. And let's do at 5, position 5, and we get the letter I. And that's because Python is a 0-based index. So this is the letter at 0, 1, 2, 3, 4, 5. So the space is 4. And the I on is actually where it's at. And you might say, well, how do you know that? There's a lot of I's in there. Well, let's just slice starting at position 5 and to the end is a string. So you can see that I'm telling it to go from 5 and stop at the last position, -1. Or, sorry, I should have just left that. Okay, so I have these laid out in a more structured way than that hackneyed explanation. So if you scroll through this notebook, you'll see that numbers, I walk through a couple different examples of numbers. All of this, by the way, is from the book, the Python book I recommended in the syllabus, which I'm having trouble. Think Python, thank you. All of this is from Think Python. So if you check out that book, you'll see all of these in there. So you can run type on these different values and understand that they're all represented as ints for different reasons. Strings. A list is another very important data type to understand. So this is a list. A list is anything between 2 square brackets and then a series of values. So for example, apple, banana, pear. I have a list of fruit. So this is a list of fruit. Let's see how long our list is. The length of our list, of our fruit list, is 3. And if we grab fruit at position 1, which fruit am I going to get?
Well, no, banana.
Banana. Yep. 0-based index.
Yeah.
Yep. I know. It's different in every programming language.
know.
Not all of them are 0-based. Also, what is very cool about Python is it allows you to store different types in a list. A list does not have to be of all one type. This is not true of all programming languages. So, for example, in my fruit list, totally valid, I could do apple, banana, pear, 7. And it will let me. So sometimes Python's a little bit, it can cause you some heartache if it will let you make weird mistakes. It will let you do weird things. That's sometimes the benefit and the curse of it. So now fruit at position 2 is actually an integer. We can see that it's an integer if we run a type on that to see what type it is. Okay, so another thing which I won't touch on too heavily here, it's probably useful for you to know, but you could probably get away with learning it on the fly, and it's a little common, it's like common sense to work with, is something called a dictionary. So it is something that some people refer to as key value pairs. So a dictionary is anything that is between two curly braces, and an object between two, and what you have is you have key, and then a colon, and then your value, and then another, and then a comma that separates your keys, key 2, and then we have a colon, and we have value 2. So this is I didn't store that as anything, so that won't be helpful. I can't reference that. My dict, now I can. Now I've stored it as something that I can actually use. So if I do this at 1, I'm going to get the value 2. You can't index into dictionaries like that. Dot key or value. Nope.
You have to do this with the key.
Well, this is going to get all the keys. Yeah. I got to remember how to do this. Dict at. Here's what we do. Maybe it is get key. Nope, there we are. You're right. Get key. So good job. High five.
I had to do it.
You're like, I know.
Unfortunately.
So dictionaries are different from lists and other objects. You have certain ways that you have to access them. And it's worth saying with some of these data types, I would just encourage you to look them up if you're really struggling about like which ones can I update and which ones can I not. There's something called mutability when it comes to these different data structures, which means sometimes you make a certain data structure and you can never change it. And other times you make a certain type of data structure and you can change it. So what does that mean? Let's look at this one. So I believe lists are mutable, so changeable. So we can just say fruit at position 3. I don't want it to equal 7 anymore. I want it to equal avocado. And, oops, 2. The zero base got me 2. Fruit at position 2, which is actually the third element. So now we can say fruit, and you can see that it says avocado now. So we overwrote 7 with avocado. You cannot do that for all data structures. Not every type of data structure will let you do that. Lists will let you do that. I can't remember if dictionaries are mutable. I believe dictionaries are not mutable. Can you? Oh, but you have to use the function.
Yeah, you have to like do it based off the key.
So these are mutable. Tuples.
I don't know.
I don't remember. Tuples might not be mutable, but you don't really need to know about tuples. We're getting a little down the rabbit hole when we get to tuples. I think that you can get through this course without being super familiar with tuples. You will use lists a lot, and you will use lists of lists a lot. So lists inside of a list. Sometimes that's how data is stored. As if you have a bunch of customers, each customer is a list, and a collection of customers is then a list of lists. So you'll use lists a lot. And dictionaries, Booleans, we will use a lot. That's comparing two numbers. So you can compare two things, and then you can get a bool back out of that. To see if that is true. There's some complexities about how that happens. I won't go into that. This one's important. In every other programming language, they use the word null, but Python had to be different. And they use the word none to represent a null value. This is important because if you see none in your data sets, or you see that doesn't mean like somebody input the word none. that means that there was actually no data in the system there. So this is their equivalent of something called a null, is the none value. So it's a none type. It means null. Python had to be different and call it something else. But it's very important because when you go to fill NA, fill nulls, this is the data type that you're looking to fill in that situation. So if you see nones, or if it says, hey, I got this value and it was none, that means there's nothing there. There was nothing in there. Printing, comments. So you guys know you can put a hashtag and then anything after that line is ignored. So this is a comment in a code. It's not actually code. It doesn't actually do anything. It's there for, you can write whatever you want. It's like notes. So sometimes you'll go through code and people will have a bunch of comments. Basically, the green stuff here is a comment. It starts with a hashtag space. I can make, like, if I just started typing, this is not a comment. And if I tried to run the code, it's going to error out because it's trying to parse code and these are words and it doesn't know what to do with these. And so you can put a hashtag and that turns it into a comment. And essentially when the machine goes through this to run the code, it ignores those. It doesn't look at anything that's a hashtag. So it just looks at these lines here and runs these. But sometimes it's useful to have comments in your code telling yourself what you're doing or other people telling you what's happening in here. You can use it for organization, separation. So these are something called single line comments. This one is something called a multi-line comment. So if you have to write a really, really long comment and you don't want to keep putting a hashtag every single time you want to start a new line, then you can do a multi-line comment. That is everything between these two things. So you could do start this and we can close it. Oops, we can close it. Oh, no, sorry, not that kind. This kind, got that? And we can close it. And then anything in here is ignored by the computer. So when it's processing it. So that doesn't do anything. It's just helpful sometimes to us as humans. So if you see, some of my code will probably have comments in it, for example. You ask ChatGPT to write you code. It puts comments in it. So oh, by the way, if you guys are struggling with Python and stuff, I do recommend that you guys use ChatGPT in your homework and in your assignments. I think it's silly to constrain technology, especially since we are teaching an AI class. Do be aware that it is wrong sometimes. In my personal experience,
For sure.
I was teaching one of the classes and I do use it sometimes to help me make faster slide content and faster. I know what I want, but it writes it a lot faster than I do. And I was presenting the formula for cross entropy loss. And I started describing it and then I paused for 5 seconds and said, that's wrong. That is not correct. Not even a little bit. So it's not always right. It does make mistakes, and I've seen it make mistakes in programming. However, I do encourage you to use it. It is useful to know what your code is doing, but it can help you get started, and it can help you do your homework a little faster. I do recommend it. You are allowed to use it for your assignments. I'm not going to restrict that. So you cannot change the value of some things. So for example, we cannot make a variable called 3 because that is something called a protected value in Python, which means that 3 is so important that if we change the value of 3 to like 7, it would mess everything up. So Python doesn't let you do anything quite that dumb. It is flexible, but it puts up a few guardrails. So the value 3 cannot be overwritten. So I can't do 3 equals A. Also, everything that your expression has to go, whatever your assignment value is, whatever you want to call the thing, and then your operators and anything you want to do to it, all of your logic has to be on the other side of the equal sign. So just like math, this will always be Y, for example. It would just always be one variable of what you're going to refer to it as, all of your operations on this side. Let me see what else is important here. You guys can look through numeric operations. They're really straightforward. Add, divide, multiply, add 1, take to the power of. And also, I think ChatGPT and Stack Overflow will get you a long ways on any of those. If you don't remember, it's a very quick Google away. Excuse me. String operations, I don't need to focus on that. You guys will figure that out. I think they're conditional statements. So, how much time we have left? We got some time. All right, so I think we reviewed data types. Are we feeling good about data types? All right, you guys have what you need there. This is awesome because we'll see. Maybe you guys will feel overwhelmed. I get the sense that you guys are feeling good and comfortable with the Python stuff, which is good. The reason I have this in here is because in my last session, I think there was a bit of a gap to cover in the Python stuff. So if you guys are good, we'll fly through this stuff. The other thing that's useful that you will use is something called control structures. So this determines where the code goes, what it executes at what point in time. And so there are probably 2 things I want you to be familiar with: loops and conditional statements. I'm not necessarily going to ask you to dig into the details of break, continue, pass, but I want you to be familiar with for and a while loop, at least a for loop. Like while is bonus, but you need to be familiar with a for loop. We will use those a lot. And you need to be familiar with if, else, and elif. So let's look at those. They're really straightforward though. What's great about Python is it's written in a way that you can like just read it and it makes sense. So we set A equals to 33 and B equals to 200. If B is less than A, then print this statement: B is greater than A. Otherwise, you're going to print this other statement: I'm not in the loop. So if I run this, great, I'm not in the loop. And now what happens is we assign A, we assign B, we hit this conditional, it finds that B is in fact greater than A. This piece of code never runs. So technically, I can put a bunch of stuff here that actually wouldn't even like make sense, and we'll see if I get a compile error. Oh, I lied. Python was smarter. Darn it. Let me think of something else that wouldn't make sense. I can't think of anything. Okay, so it pre-compiled for me so that it didn't let me do that. But so I'm not in the loop. So what we can do is we can now change let's flip this sign. We could either change the values or we could flip the sign. Some way we want to get in the loop. And let's see what happens. Oh, interesting. It says B is greater than A, and it still says I'm not in the loop. And that's because this is not part of a conditional statement. This is just back to the code, back to the regularly scheduled programming, and it will execute no matter what. I skipped something, which is that Python is an indent-based language. Indents are very, very important. So what you do with your code is important. Let's change back to the original thing I had here. And let me remove this indent, and it will throw an error if I don't put something in here. So let me just put something. So let me just remove this indent here and see what happens. It's going to print both, even though we didn't go inside this loop, because it's all indent based. Other languages use curly braces. I actually personally prefer that. I think it's more organized. It's a little easier to understand when you get to larger segments of code, but this is Python's way. So your indents are important. So everything indented inside of this conditional will happen. Everything not indented outside of this conditional will not happen. So that's if. Well, what if we wanted it to do something if that was true, and something else if they were equal? And if neither of those situations were true, we wanted it to do something totally different, but we didn't want the print that happened all the time, even though that was true or not true. So then that's an if else. So we can say, hey, if B is greater than A, do this. If it's equal to A, do this. Otherwise, print that they're greater than A. So you can do that one. You guys can explore more of these. They get more nuanced. So I don't know. This isn't a programming class, so we won't, I'll just try to give the useful ones. What we will do with these for statements, we're in if. Let me get to for. Okay. The other important thing is for statements, which we will use a lot because we have data. And we want to do something called iterate over our data. So we want to go loop through the different examples. And so we'll use for to do that. So for fruits, for example, for X in fruits, print X. We want it to do something with that fruit every time that we loop over it. So that's what a for loop is. It's a control statement, and all of this happens to each fruit each time it goes through the loop. I'll send you guys videos because I feel like I touch on these very lightly, and there's probably more. We don't, I won't even put while on. It's not necessary, but for loop for sure. If, else, elif, that's fine. Okay, so conditional statements, for loops, and if statements. When we get to data structures, I don't know, tuples and sets, fine, but lists, dictionaries. So we talked about those already. We won't talk about any of the other ones on the right. Okay, and then the final thing that you need to know, let me see if it really is the final thing. Yes. Okay. Final thing from a Python basics perspective, before we get to the actual packages. Everything I've talked about here, by the way, when we talk about variables and data types, control structures, data structures, and functions, these are all something called like Python native. It means you just work with Python, you get it. You don't have to import anything outside of the Python library. So this is a part of the core programming language itself. After we talk about functions, we're at 9. Okay, next week we will talk about a package, and that's called pandas. And this is not core to Python. It's something you import, and it's something that you use to help you understand data. I'll let you guys explore functions on your own. I'll tell you that you should know them and that it will be useful for you to know them, because essentially everything that we're going to use will be a function. What a function is sometimes you write code and you don't want to copy it 10 times. You want to be able to use it, but you don't want to copy and paste it and copy. So what if I made a calculator that every time it saw a plus, it added? Every time it saw a minus, it added. Well, I want to reuse that code. And so in Python, you can make some syntax. You can say def means I'm going to define a function. You're telling Python, this code here will now be a function. Then you're going to say, I want this function to have this name. And then here are some arguments for that function. And I want you to print this, and then I want you to return X, Y. I'll let you guys explore functions. They're important. I have some examples in here. And we'll cover these last 2 slides, pandas, next time. In summary here, just a reminder, A0 will be due on Monday. So you have the weekend. You don't actually have to do it. I'll make a video on how to submit it. Not actually have to do anything other than no code to program. You just have to come into that Colab notebook, execute all of those cells, make sure they all say okay, make sure that your output matches here and you're not getting any errors, basically. Then download it and then upload it.
Download it from your Google Drive.
Yep. So after you're going to, I'll make a video.
Yeah,
that walks
When
through
are
the
you
steps.
planning on making the video?
Tomorrow.
Okay.
Tomorrow. Yep.
Would I have access on Slack, or how would I get access?
Oh, you know what? Let me just email you
Because
access to all these docs.
Crystal Ball of not having access to Slack, and
Let me stop the recording here. And we'll do after hours.
so I'm afraid I don't know if I will have access to.
End stream.